Welcome to Image Processing with ArcGIS Pro. 12 YouTube videos summarize image processing lab exercises available in a step-by-step lab manual that accompanies this textbook. Download the lab manuals at the site shown and obtain more textbook information at the second site shown publisher's website. Download the lab manual and data used in the lab exercises if you want to use the step-by-step instructions and process the imagery and DEMs while viewing the YouTube videos. The examples used in the videos and lab manual are discussed and shown in the textbook, improving GIS student understanding of essential remote sensing principles and technology while learning how to process and enhance images and DEMs using ArcGIS Pro. The lab manual, a page is shown in the upper right, and 12 YouTube videos are designed for GIS instructors, students, and users who want to do their own processing, enhancement, and information extraction of satellite and airborne images and DEMs using ArcGIS Pro. You can see the 12 exercises, the tutorials listed here. They cover a broad range of image processing tasks, algorithms, and help you find where these tasks are located on the various menus in ArcGIS Pro. The lab exercises require ArcGIS Spatial Analyst extension. Contact Ellis at ellis-geospatial.com for any questions or comments, and visit the publisher's website for more information and resources on the textbook. Lab 4 covers using multispectral imagery to develop vegetation maps, do a density slice, and then convert the raster image to a vector file like a shapefile or a feature. Tasks we'll be doing are going to be divide two bands to create simple band ratios. The one we'll do is near infrared over red, which is the SR. Do the little more complicated NDVI band ratio, which is very popular for greenness mapping, and then generate a density slice from that band ratio and generate a raster thematic map from the raster image that we created with the density slice, and then change that thematic map into a vector polygon map. We'll be using the same scene that we used in Lab 3 of Thermopolis, Wyoming. It's a Landsat 8, a subscene, but this one's been atmospherically corrected, which minimizes the effect of haze, clouds, and so it really cuts down the haze in the blue, green, and red bands. And you want to do that before you do ratios. So we'll only be working with band 5 and band 4, the near IR and the red. And remember, when we look at it in ArcGIS Pro, numbers this near IR is number 4, and the red is number 3. Here we're looking at the US, and we'll drag our Landsat scene into view. It comes up in pretty dark colors, so let's brighten this up a bit and see what's going on. So we have 1, 2, 3. We'll just put a little standard stretch on it. Unusual to see rocks as blue, and so we look at this and we say, band 1 is red, 2, 3. So we go back to our options, and remember the options, how we set this up. If we go to raster and imagery, our multispectral data, band 1 is loaded into red, but with Landsat, band 1 is actually the blue. Band 2 is green, and band 3. So we need to reverse these if we're going to work with a lot of Landsat, or change them in our symbology going forward. So we'll change them over here. And you'll start seeing the appropriate colors. These rocks actually are very reddish because they have iron in them. Now to do a simple ratio, we go to the imagery tab, and a very efficient way to do it is over here, and so you can actually see the SR, simple ratio. But we're not going to use this. We're going to go over to raster functions so that we see tool flexibility. We go to math and band arithmetic. And what's our raster? The Landsat, the method. Now you can go to the help section, which is the question mark up here, and can you see that? Which is fabulous. It explains what each of these ratios does. Click on the SR, and then we have to type in what bands, and it'll be 4 space 3. And it comes up with a 32-bit image. That's the band ratio. And if you're going to do a lot of these, you want to relabel this and just say this one is SR. Now let's go to our appearance And we can go to the Symbology tab. Let's go to Symbology tab and stretch this with the minimum maximum. Doesn't have statistics. Yes, we'd like to calculate them. And you can see it's pretty dark, pretty subtle, and hard to get a handle on what's going on with this NDVI. So let's do a percent clip. Now what it's saying is that the brightest pixels are the ones with the highest greenness, vegetation greenness, or the most vigorous vegetation. With the simple, we're doing the simple SR ratio. Now we want to look at the histogram, but you can see that it's faded out. And so what I've found is that sometimes I have to go through and click Symbology again from another source, and my histogram comes up. And so this is showing the distribution of the brightness values in this simple SR ratio. Let's move this to 0. Move this out to 15. Let's see what it looks like on our image. So we first want to zoom in and change the resampling if we're going to start querying the values to nearest neighbors, so we can actually zoom in on specific pixels. And then we go to Imagery, Information, and you can see on the right side this one's 13, 18, 19, 21. When I go into the dark, it's a very low number, 1, 2. So we can actually query each pixel, and you can see this is a very well irrigated field. Values up in 42, 40. Now let's move this, we'll go back to Symbology, and we want to break out what's happening in this very bright area. So let's say move this out to 25, and you start to see some subtle, move it out to 65, and now you're getting a much better idea which pixels are actually the brightest in this field, which ones are darker. So again, we go to the Information tab, and now we can come up with specific locations. And when this pop-up is up, you're getting the values. Hopefully you can see that. It's pretty small text. Very effective way to query individual pixels. And so I'll close this, zoom to the layer. And black and white isn't necessarily where we want to be, so we can go back and make a different color scheme. And so show the names of these, and you see they all have, like, this is basic random, and if we go quite a ways down, we'll come into one green continuous, blue-green continuous. And so that's a good rendition of the brightness values for the pixels in the SR ratio. The darker the green, the more vigorous that particular pixel is. So I'll zoom back out, turn this one off, turn on my band ratios, and go back to, say it's Symbology, and go to these indices. I have to click on the multispectral image and the indices, and you can see the iron oxide. If you're interested in geology, that'll be the red over the blue. The clay minerals is the SWIR 1 over the SWIR 2, which brings out those pixels that have clay being absorbed would be darker. And so you can see it's quite a good menu. We'll click on this NDVI leaf. Up comes the question about what bands we want to use. Let's go to 4 in the near IR, 3 in red, and that's it. Hit OK, and there it is. Once again, a 32-bit image. Needs to calculate statistics. We can see it looks very similar to SR, the simple band ratio we did, but this is NDVI. And what we can do is, this is a little confusing. This is the maximum number that ArcGIS can hold. So I'm just going to change it from -1 to 1, which is the range that NDVI actually comes in. Most NDVI values over vegetation are between 0.2 and 0.7 to 0.8. So you can see the histogram is grayed out, and what I've found is if I come over here, do Symbology from another source, it becomes active. So there's my Symbology, and you can see if we move this bar over that we get to 0, and the vast majority, well, all the pixels are above 0, so that's our range. So we'll move this 0, make sure this is at 1, And you can see as we move them around, we start to get a pretty nice looking NDVI grayscale image. Now we'll go to the information tool and we'll zoom in to this irrigated agricultural area. And this is an issue I've come up with in the last 3 times I've tried this on a 32-bit NDVI. And you see I only get 1 and 0 is the only value I get over here in this little indicator box of what is the pixel value. And that's not very useful, and I've closed the project, opened it up again. And what's interesting, if I save this as a permanent GIS ready TIFF image, that it works with the query tool in desktop, and it works in some processing software like NV. So this is just a glitch that I seem to have run into. So I cannot tell what the highest and lowest pixels are unless I go back to the histogram, and I can see as I move this around what the different values are. It's just some bug that I seem to have come in contact with, unfortunately. Now we really only want to look at pixels in the field that have really green vegetation. So we'll just say, for the sake of argument, I'm going to look for pixels with a NDVI greater than 0.5, and that's showing up in this image now. So we've narrowed the number of pixels we have to go to, and what we want to do is convert this into a thematic raster map. So I go to symbology again, and I click this back arrow, and instead of doing stretch, I go to classify, and instantly it classifies it into 5 classes, the image, and I only want 2. So I go up here and I say I only want above 0.5 and below 0.5. And you can see it works really well. And then I can I don't really want to see any color in that, and I want this to be dark green. And so what we want to do is change this value to 0.5. And you see it shows up in the table of contents. Has an NDVI above 0.5, and I can bring in other GIS layers, like say the Wyoming geological map, and then I can say, if I go to appearance and I use my swipe tool, I have to touch the NDVI on top, use my swipe tool, I can start to see what geologic formations support this irrigation. And if I want to pan, notice I can't pan. I have to hold down the C key, and I can move across, let go of the C key, and my swipe works again. So I'm able to interrogate and ask questions because I'm in GIS about where is this irrigated plots with NDVI greater than 0.5, what sort of geological formations do they occur in. So now we want to turn this raster map into, I'll turn off all these, I'll zoom to it, into a thematic map, which allows us to convert it to a vector polygon file, like a shape file. So I go to geoprocessing, and I know the term is reclassified, so I can type it in. If I didn't know that was the term, I have to search around, and I'm using the spatial analyst version. They're identical, but I'm not needing 3D analyst for this lab exercise. And there it is, reclassify. So I can double click on that. The input raster is my NDVI. I leave all these the same. I want to change the name though. You see I get back to my lab 4. I've done this once before, so these are very green pixels. And you have to have .tiff to make it work. Now it's running. I'll turn off on, and this is my thematic raster map, and you see it's got an attribute table. So it's telling me that 104,692 pixels have an NDVI of greater than 0.5, whereas 1,330,000 are less than 0.5. And we can do the same thing. We go to symbology, as long as that thematic raster map, and we can change this I have to click the left button, no color, and it's identical to our previous raster map, but now it's got an attribute table. Now I'd like to convert this raster thematic map to a vector polygon shapefile. And so I go to geoprocessing again, and I can go to toolbox. So I go click back here. Remember the toolboxes? And so if I close this one, and I go to the very top, conversion tools. I had this in the first lab, from raster to polygon. The input raster is our very green pixels, and we'll change the name to the polygon version 2. And I don't simplify the polygons. If you do, it degrades the map that you're making, but if your computer's not good enough and there's too many polygons trying to be generated, it might crash your program. So you have to make the decision based on your computer capability. And so now we've got, I can move this. What's nice about all these windows, you can move things out of the way. Slide it over here. And so here's my shapefile. We don't want just one color. I have to click the right. We want to go to symbology again. And instead of a single symbol, we'll go to unique values. And we'll go to the grid code, which we can see has a number 1 and number 2. And again, we can you end up with this, when you first click on that, you end up with all these canned colors, and you have to go to properties and to do your own work. And then say apply, and then go to back again, and we'll change this just like we did the other ones, that dark green. So we've made 3 different maps, all different properties in the GIS world, and they're telling the same story, except this one has an attribute table, which makes it much handier. And you'll notice that I go back again, I can get rid of this all other values by just going up here to more and unclicking. And I'll save my project. Now we'll come back and we'll start working with the table and see if we can come up with how much area is included in my area that has NDVI greater than 0.5. We can look at the attribute table for our shapefile. You can see in the grid code it's either 1 or 2. And I want to dock that, see if I can dock it in here. Oh yeah, it's really clever. So now I've got my pixels, said there's 104,000 pixels that had 0.5 and higher, and now I've got this grid code. And so, as I said, the next thing we're going to try to do is what's the area that is included in terrain that has NDVI values greater than 0.5. So now what we want to do is calculate area, and so we want to add a field, and we'll call this area. I'll call it area 2. There. We'll just make it numeric also. You can see all the different. I don't need this many decimal places. See if it actually, let's move this up above, you can't see. And then we save this change. So let's use the calculate geometry. There's our input, area 2. We'll say calculating the area. We'll do it in square meters. The coordinate system is what all the raster imagery and shapefiles are in. And let it run. And it should fill in area 2 with the square meters. And there they are. So these are the square meters in each one of those polygons inside that green shapefile up above. And then if we want to get the total area, I go to summarize. And the field is area. And the case, I'm doing it according to the grid code, so I should just get 2 fields in the table that's generated. And if we look over on the left, we'll see there's a table. and I open this table, and it's very clever. I should be able to drag it into this menu, and there's the answer. 94,222,800 square meters. So I would want to change this into square kilometers if I continued on this inquiry about how much area's got NDVI values greater than 0.5. So that concludes this lab 4. I'll save and close.